Hi, my name is Josie West, and today I'm going to be going over problem set number 1, question 8, which has to do with determining the energy/heat of a freezing curve process. So this question is asking, if you have 155 grams of water at 32.5 degrees Celsius, how much heat in kilojoules is involved in the process to convert all the liquid to solid at negative 5.5 degrees Celsius? So this is going to occur over a period of 3 different heat intervals. So I've created this little diagram to show us such. And we are going to have 3 temperatures involved. The first one, given to us in the problem, is 32.5 degrees Celsius, which is where we're starting, which is also, we can see, is point A on the diagram. And then the second temperature is going to be the freezing point of water, which is 0.0 degrees Celsius. And that's going to be point B, and then that's going to fuse into a solid, which is point C. And then finally, it's going to be further cooled to negative 5.5 degrees Celsius, which is point D on the chart. And so each individual segment I've labeled Q1, Q2, and Q3. So to find the total heat, which is what the question is asking for, how much heat in kilojoules, we're going to add these 3 different heats together. So Q1 plus Q2 plus Q3. So now we have to go about actually finding these. So for Q1, we're going to use the equation Q equals mass times specific heat times change in temperature. And we are given the mass in the problem, which is 155 grams. So we can say Q1 equals 155 grams times the specific heat. In this case, we're going to say the specific heat of liquid because it starts as a liquid, as it says here, convert all the liquid. So that's going to be 4.18 joules per grams degrees Celsius times the change in temperature. Now this is going to be the hardest part for this one. So delta T is equal to the final temperature minus the initial temperature. And in this segment here, we can see we're going from A to B. So our final temperature is going to be 0 degrees Celsius. And our initial temperature is going to be 32.5 degrees Celsius. And when we multiply all of this out, we're going to get that Q1 is equal to negative 21,056.75 joules. And this is important. So grams cancels out with the grams, and Celsius cancels out with the Celsius, which leaves us with joules. However, the question is asking us for heat in kilojoules, so we're going to have to convert this to kilojoules. And to do that, we're going to use the conversion factor, which is 1 kilojoule over 1,000 joules. And this is going to give us that Q1 is equal to negative 21.05, and then we'll just round here, 7 kilojoules. So this is our Q1. Now, Q2 is going to be a little different because this is the process of fusion. So instead of using the above equation, we are going to use that Q2 is equal to the number of moles times delta H. And in order to get number of moles, we're going to multiply the mass, which is 155 grams, times 1 mole, and this is of water again, over the molar mass of water, which is 18.02 grams. Now, we want to use the delta H here of a solid because it is becoming a solid. So we're going to say times negative 6.02 kilojoules per mole. Now, when we multiply all of this out, we are going to get that Q2 is equal to negative 51.781 kilojoules. And again, I'll show the units for this. So these grams cancel out with this, and these moles cancel out with this mole, leaving us with kilojoules. And since it's already in kilojoules, we don't have to worry about converting it. So this is our Q2. Now, our last thing we need to find is Q3. And because, once again, this is a cooling process, not a fusion process, we're going to use the same equation we used to find Q1. So Q1 equals M, Q3 equals M times specific heat times delta T. So our mass stays the same. We still have 155 grams of ice now. Our specific heat, however, is going to change because now instead of a liquid, we are actually an ice. So we're going to use CS ice, which is 2.09 joules per grams degrees Celsius. And then our delta T is also going to change because we're going from C to D. So our final temperature is negative 5.5 degrees Celsius. And our initial temperature is 0.0 degrees Celsius. And when we multiply this all out, we are going to get that Q3 is equal to negative 1,781, and then 0.725 if you want to keep it running. Joules again, because I'll show this again. Grams cancel out with grams. Celsius cancels out with Celsius because this is all one. And then we're left with joules. But once again, we're going to have to convert this to kilojoules. So times 1 kilojoule over 1,000 joules. And that leaves us with Q3 equaling negative 1.78, and then we'll round again, 17 kilojoules. So now that we have our 3 heats, we're going to remember that our total heat is equal to the sum of them. So now we're going to add them all together. So Q total equals Q1, which is negative 21.057 kilojoules, plus Q2, which is negative 51.781 kilojoules, plus Q3, which is negative 1.7817 kilojoules. And that is going to yield a total of negative 74.6197 kilojoules. But we have to remember sig figs. So if we go back to the original question, we can see that because we're multiplying, we can see that the smallest number of sig figs that's limiting us is this negative 5.5. So our final answer is going to require 2 sig figs. So Q total is going to equal negative 75 kilojoules. And that is going to be our final answer. Thank you.